Hi, today we are going to talk about soil, okay? We're going to talk about what soil is, the parts of soil, its composition, and its forensic value. So you should have your soil notes out in front of you and be ready to go. So first thing we're going to talk about is what is soil. For forensic purposes, soil is any disintegrated material that lies on or near the surface. Okay, so there's lots of definitions, kind of scientific definitions of soil, but for our class and for forensic purposes, it's any disintegrated material that lies on or near the surface. So it can include pollen, it can include flowers, it can include glass fragments, it can include rubber off the road, any disintegrated material that lies on or near the surface. Okay, so naturally deposited materials covering the Earth's surface and anything capable of supporting plant growth also fall kind of into our realm of what we're talking about for soil. Okay, a lot of times for forensics, we're dealing with kind of two parts: the very top and what's on it, and what we can find useful for us, and then if there's a body or a weapon or something buried below the surface, at what level are we at? So as far as soil formation goes, okay, there are 5 kind of factors that play an effect on how soil is formed. The first factor is the parent material itself. It's the material from which the soil is formed. Is it formed from bedrock? Is it formed from organic matter, deposits from glaciers? And depending on what the parent material is will depend on kind of the nutrients of the actual soil itself. Like really dark black soil that's good for growing crops and plants and things like that, that's found like in the Midwest, its parent material is organic matter. Like in Arizona, our parent material is bedrock, which is why our soil is really hard and rocky and not really great for growing things. So the parent material itself, kind of what the soil is formed from. The climate in which you're in plays a factor in soil formation. Heat, rain, snow, wind, sunshine, etc., will decide how fast or slow soil processes go. If you get a lot of heat like we do in Arizona, right, our soil formation doesn't happen very well. Okay. If you're in places with a lot of rain and a lot of sunshine, you end up with very nutrient-dense soil, usually thick clay-like soil. And then if you have a lot of wind, you may not have a lot of soil because it continuously gets blown. That top layer of soil gets blown away. Organisms, all plants and animals living in the soil. And the more organisms you have living in the soil, the better your soil usually is, right? Worms, bugs, all that type of stuff. It tosses up the soil. It provides nutrients. It provides air and water locations in the soil. So the more organisms you have, the better. Topography, this is the location of the soil on landscape. Think of like soil on the side of a mountain versus soil on like a flat land. Soil on the side of the mountain is not going to be as good because every time there's rain or snow, it's going to slide down the side of the mountain with the liquid, right? With the rain or the snow. Versus like a flat plain land, right? You're going to have good, better soil there just because of the location. So topography, and then time. Time is the 5th factor that plays into soil formation. The more time you leave soil alone, the better nutrients and the denser that it gets. If you overuse soil too much to an extent, you can kind of almost like kill it, where you deplete it to the point where it has no nutrients in it, it has no organisms in it, anything like that, and it becomes kind of almost unfunctionable. That's why farmers a lot of times, like they'll use a plot of land for say 5-6 years, and then on that 7th year they'll let it rest for 2-3 years, and they'll let it kind of just regroup, and they'll let it just sit by itself and let it just reproduce its nutrients and its value in it, and then they'll use it again because they know that if you overuse it, you can potentially get to the point where it won't produce anything. Taking a look at the soil profile. This is kind of important because when they're talking about where they find evidence at and they're talking about soil horizons, you need to know, is it, the substratum, the subsoil layer, the surface horizon, etc. So when you're talking about a soil profile, think about if you were to take like a piece of cake and you were to cut a piece of cake out, like a sliver of cake or a slice of cake out of a whole cake, and you could see all the different layers of the cake itself. That's kind of what they're doing. They're taking soil and they're taking kind of just a whole sliver of it and pulling it up, just like what's right here. Soil is made of layers called soil horizons, and there's 3 major horizons. The surface horizon, which includes the topsoil, which is right here. It's like the black part. And the surface horizon is usually the top of the soil all the way down about 2 inches below the surface is usually what we're talking about when we talk about the surface horizon. Okay. And then you have the subsoil, and that's level B right here. This is kind of where your deep roots from your plants and things like that go. That usually goes from about 2 inches under the soil all the way to about 6 feet down. And this is going to usually be where forensic scientists are going to find like bodies or graves or things like that buried. It's usually the subsoil layer. Still soft enough to dig into, but a good ways underneath the actual ground. And then C is the substratum layer, which is the parent material. So this is like the bedrock or the glacier or the organic material. And this is usually quite a ways down. And there isn't really a reason for forensic scientists to need to get to the substratum layer for any reason. Usually, we deal mostly with these 2 levels right here, okay? The surface horizon and the subsoil. So what's right on or near the surface that can be useful to us when solving crimes, and then if something is buried in the subsoil layer. That's usually what we're looking for as far as soil profile goes. So you may want to draw the actual column and kind of label where the parts are. That would be beneficial to you. All right, so soil composition. What is soil made up of? It's made up mainly of sand, silt, clay, organic matter, and nutrients. And depending on where the soil is in the United States or the world, kind of depends on the amounts of these. Okay, so sand, okay, you guys have a pretty good idea of what sand is. Silt is kind of a finer material. And then clay, which is your really thick stuff, think like kind of almost like a mud consistency, a thick mud consistency. Silt, I would say, is closer to like the really soft, fine stuff that you would find on the beach. And then organic matter, that's your like really deep black stuff, almost like potting soil type consistency. And then your nutrients. Nutrients, things like potassium, nitrogen, phosphorus, calcium, iron, copper. Okay, that's what we're talking about there. And so depending on the location of the soil depends on its composition. So like in Arizona, a lot of our soil is made predominantly of sand and a little bit of clay-like material because it's thick. Back in the Midwest, they have a lot of organic matter and clay consistency. Towards the beaches, they have sand and silt consistency, so on and so forth. So it kind of just depends on where you're located at. And so down here it says the composition of soil is unique in different areas, which is super helpful for us because it can kind of give us a gauge of where in the area our crime might have occurred at. So soil's forensic value. Let's talk about that a little bit here. Soil comparisons can establish links to suspects. So here's one of like the big key takeaways. Please highlight this, star this, do whatever you need to do. But in order to compare soil samples, so say that you had soil from the bottom of a car that a suspect was apprehended in and you wanted to compare it with a location of a crime, the most important thing that you have to know is that in order to compare soil samples, they have to be equally dry. So you can't have one soil sample that has a lot of water in it and one sample that doesn't, mainly because the color consistency will be different, the pH might be different, the percent composition would be different. There's a lot of things that can vary if your soil has water held in it. So it's really important that you completely dry out all of your soil before you start taking a look at comparisons. And then what they can do is they can compare both physical and chemical properties of the actual soil in order to see differences and similarities and be able to say, like, yes, most likely this car drove through this location. Okay, or the soil that's on the bottom of somebody's shoe came from this general location, so on and so forth. The physical properties that we're going to take a look at in our labs are density, particle size, magnetism, and mineralogy. So what's the density of the actual soil? What types of particle sizes are the particles in the soil? If it has any magnetic properties, and then what type of minerals we find in them. For chemical properties, we're taking a look at pH. Okay, what's the pH of the soil? Is it very acidic, very basic? And then any trace elements that we might find that we could take a look at. Soil is so unique that the chances of soil properties and composition being the same is so small that it has really high probative value in court. You're going to want to write that down as well. Because soil has such unique consistencies with it, because so many different things go into it, the chances of like your truck driving through red dirt, like Sedona area dirt, anywhere else in like the state of Arizona or the West Coast is so low that it would be a pretty good idea that that was where you had been. So here's some ways to determine if soil is an individual or a class characteristic. Technically, soil is a class characteristic because you're going to be looking for properties that it has in common. It's red, it has a clay-like consistency, so on and so forth. And you could say that was from Sedona, but could you say it was from someone's specific yard in Sedona? Probably not, right? Or a specific location. You can just narrow it down to a certain area usually. However, when you're analyzing soil, if you find any rare or unusual minerals, rocks, fossils, any manufactured material, or pollens, that can help you really narrow it down. So for example, if you found a red dirt that was clay-like and you were in the Sedona area, and then you also found mixed in it little purple flowers, and you found some blue and gray, like hard clay-like material, and you end up at a suspect's house and they have the purple flowers in their yard and they're making pottery, and there's a smashed pottery glass that has the blue and the black pottery that you found in the suspect's shoe or in the suspect's car, then all of a sudden your probative value increases tenfold, and now you've individualized that particular soil. So if you find something rare or unusual in the soil that you can use to say, yeah, we're sure it came from this exact location, then you've individualized it. Otherwise, soil is usually considered a class characteristic, and you can narrow down a location with it pretty successfully, but it like an exact location in terms of like this person's front yard is a little bit harder to do. So is soil individual or class evidence? It technically could be either. Most of the time it's considered class. Similar characteristics to primary or secondary crime scenes. A lot of times it can help establish timelines. Like if somebody's driving cross country and they have dirt from Arizona, and then there's dirt from say Colorado, and then there's dirt from Minnesota, and it's all kind of clumped on their car in different locations, it can kind of give a feel for the direction that they headed. And then individual characteristics, unusual ingredients, pollen, seeds, vegetation, or small fragments that are found in the soil that can be specifically linked back to a spot, then you could individualize it. So technically soil can be both class or individual depending on kind of how much information you can get out of the soil itself. So I would like you guys, now that you've finished your notes, once they're completed, I want you to take and do a summary of everything we talked about. I want you to include your top 3 most important things. So if you had to choose the 3 most important things from what we just talked about, that's what I want you to write down in your own words and your own sentences for the summary of soil at the bottom of your notes.